All right, hey guys, thanks for coming to the Intro to CAD session. It will be taught by Alex and Taylor. So whenever you guys want to take it away.
All right, first of all, does everybody have Fusion 360 on their computer? Did everybody get that downloaded? No? Mike, come on. Hey, that's right. If you don't have it, you can watch along, maybe download later and you can rewatch the video or something like that. But this will just be a quick flyover of what CAD is and then the basics on how to use it, because once you know kind of the basics on how to use it, you can do pretty much anything you want. All right, host can you enable screen sharing, please?
Okay, I made you co-host, so I think it should work now.
Okay. Okay, let's see. I want that one. Yeah, great.
Hey, there we go.
Awesome. All right, well, welcome to the introduction to CAD, everybody. So, first of all, for those of you that have no idea what CAD even is, it is an acronym that stands for computer-aided design. It is used in like every field imaginable that deals with like physical space. So mechanical engineering, civil engineering, architecture, design, even things that don't deal with physical space like game design and just art in general also use CAD.
Or even
it's just
theater too.
Yeah, even theater. It's just kind of a way to put your ideas in a more technical and more professional format and maybe visualize them better than you were able to before. So quick run through of some of the programs that you can use. So CAD, like I said, is used for everything. Some of the programs that are used for mechanical and civil engineering, a lot of them overlap, but the one we will use today is Fusion 360. Solidworks, Creo, Rhino, and Inventor are all very similar. And then Civil 3D and Revit are typically used for civil engineering, but also very similar. And so these are called parametric CAD. So there's like parametric CAD and direct design CAD. And direct design is like, we're going to take a box and this box doesn't have to have like dimensions yet, but we're just going to kind of get the general shape. It's kind of like rapid visualization, but on your computer without like the fancy ability to draw. And then parametric CAD, which is what we're going to be doing today, is everything has dimensions. We know how big it's going to be. We can give it tolerances. We can put angles on things, so it's very exact. All right, so does everybody have, I guess you don't need it, but if you have a piece of graph paper or a piece of isometric paper that we asked you to print off, now would be a great time to use it. We're just going to do a quick run through of one of the items that we're going to make in CAD today. This is kind of a good practice of drawing what you are going to design later in CAD. On graph paper first, so you can kind of have a better understanding of what exactly it's going to be. So
and then this is super jank because I don't have a webcam. So I use my smartphone in vertical mode. And I had to like mount it on the tower you see in the top.
I'm just gonna.
So the first thing you always want to start with is your name and the project you're doing when you're drawing it out on paper. So I named it Chair 101, just fun out. And then I wrote down the date. You could speed it up if you want, Taylor.
All right, we'll go 2 times speed.
Awesome. And then on the right-hand side, you always write how many sheets you're using. So I put 1 out of 1 because I'm only going to be using 1. And then you always want to have units too. So you can't really see it in the video, but engineering paper has a bunch of small little boxes, just like grid paper. And so I made one of those boxes, actually 6 inches. I wrote that wrong. I actually correct it later in the video because I underestimated how much space I needed. And then so the 4 main views that you have when you're drawing is you have your top view, you have your front view, and you have your side view. And then the last one is the isometric view, which we don't do on grid paper. We actually do it on isometric paper because it's much easier to try to do that. And so I start with the top view, and this is looking down on the chair from above. So this is exactly what you would see. So I'm making it, well, actually it's not 4 units, but it's actually 2 feet because 6 inches times 4 is 2 feet. So it'll be a 2 feet by 2 feet chair, which actually is pretty small. I didn't really think this through. So, and then your solid lines that you're drawing on it, that's what you can see. And the dotted lines are your hidden lines. So that's what's behind it, or what you cannot see in the picture itself. So the solid line there is where the, I don't know what you call the back of a chair, I guess. And then I put the legs underneath as hidden lines because you can't see those. And then so for the front view, we have the front of the chair. So it's like if you're directly looking at it. And so that's the back of the chair. And then this is the where you sit. And then these are the legs for the chair. And then for the side view, it's basically taking the front view and just flipping it like this. So as you can see, it gives it depth. So you can see that's the top of the chair, and then that's where you sit down, and then I'll draw the legs after that.
You'll also notice the dotted lines that he put in between views. That's kind of a helpful tool. You can't see really in the video where the grid lines are on his engineering paper, but he followed the grid lines down in order to make sure that the front view and the top view were the same width, so his chair isn't wider in the front view or in the top view.
Awesome. And now we'll move on to the one that I made on isometric paper, which you can actually see the lines on this one. So the way I usually start with isometric views is I draw the bottom of whatever I'm making. So in this case, it's the bottom of the chair legs. But I didn't draw the last one because you won't be able to see that at all because it's being covered up by the rest of the chair. And then I draw basically the process is copying from the views that you've made, but making sure to erase anything that you won't be able to see in person. So like on the chair legs, as you can see, there's still the boxes there, which make it very confusing. So you would just erase those and it would look perfectly normal. And so this whole video is basically me just drawing from the grid paper that I was using earlier.
So
Do you have
this
anything to add, Taylor?
Yeah, so this whole like drawing on graph paper and isometric paper isn't necessarily required, but it makes it a lot easier when you switch to making your object or whatever you're making in CAD, because then you kind of have like a game plan for what you're going to do. And in addition to that, lots of times when you make something in CAD, I don't know if you're not a mechanical engineer or civil engineer, this oftentimes won't apply for you, but if you're making it to manufacture or you're making it to like actually construct, you'll create a drawing afterwards, or a drawing for the manufacturer. And so that'll be the 4 main views so that the manufacturer can see on just one sheet of paper what they're actually building. So yeah, you can see the 4 main views, and then Alex is showing the directions in which you'd be looking at it in isometric. So yeah, why don't we go ahead and get started in Fusion. I'll stop sharing so you can, Alex.
Awesome. I've never actually shared a screen in Zoom before, so this would be interesting. Oh, there
So
it
if you
is.
have
Okay.
Fusion 360, this would be a great time to open it up. Alex is going to walk us through building that chair, and then right after that, I'm going to walk us through building a table using some different functions.
Awesome. Can you guys see my screen? Okay, cool. So the first thing we want to do is establish our origin. So on the left-hand side, you'll see a folder that says origin, and you want to open that up. And then you can see visibility here. So you can see all the different lines and all the different dimensions. And so we want to make sure that our visibility is on for our 3 planes. Actually, I don't know what's going on. Okay, so they're there. So if you shift click on these three, you can see they're there. I guess in it's much easier to do this in Inventor. But we're going to be doing ours on the flat plane, so the XY axis. And so you can either click this button here to create a sketch, or you can right click on the plane and create a sketch there. And then we'll start there with the chair. And then the first thing we're going to do is the legs. So you can either do it using a line. So here, if you select the line tool up here, am I going at a good speed or am I going too fast? Okay. So then we know that it's, well, the chair leg was 6 inches by 6 inches. So that'll be 0.5 feet. Actually, that's pretty confusing. So I'll just do it in feet. Screw it. So I'll make it a super huge chair. So it'll be 1 foot by 1 foot, and then you can basically use lines for anything. So if you wanted to make a polygon or something else, you could definitely do that. But a much easier way to do it also is by using the rectangle tool. Now the rectangle tool will allow you to just draw a rectangle just like this. And it's much easier than having to draw every individual line, and it already dimensions it out for you. And so you'll see here that these lines have a black, or it's black, and that's because it's a dimension line. Now on this picture, they have blue lines, which means it's not dimensioned, even though I said in the rectangle tool that it was. Now in order to make those black, we just select our sketch dimension, and we select the line, and then we put what our dimension should be. And that is 1 foot. Actually, did I do that right? I think I did that right, but it's because I don't have it tied to anything. See, this is tied to the origin, so it can't move at all. But this one, I can move anywhere I want. So in order to dimension that there, we can use these different constraints here. And there's a ton of them. It's honestly a science, and if you can master these, because it's very difficult to do so. So if we want to make them coincident, I think that's what it's called, then you can select whatever line you want to do. So let's do this line. Maybe that's not it. Okay, we're gonna do it a different way. Collinear, that's it. So it'll make the lines equal. So now if I try to move this, I can only move it in this dimension because it's constrained, because it's saying that this line has to be at the same height that this line is at. And then so we know that the distance from our picture that we drew, or that I drew, is, so it'll be 4 feet wide total. So in the middle, there has to be 2 because we've already used 2. So then we would just put a dimension there. And then I'm going to use the same process in order to do, man, it just started raining, okay. I'm going to make the other 2 rectangles using this exact same method. All right. So we want to dimension these. And obviously I'm not being very, how would I say it, nice about these dimensions. A lot of people like to make them look nice, and chain dimensioning is not something we do in engineering, which is like, if I put a dimension here as 1, and I put a dimension here as 2, that's not how, and on engineering projects you want to do it. You want to do it from here to here is 1, and then you measure from the same point again to here. So that would be 3 from there, and then to 4. I'm just doing it this way because it's much quicker in my opinion. And then now we want to do this, perfect. And then how can I stretch this? Okay, so I can stretch it like that. So I need to make this 2, or I'm sorry, 1. What am I doing? And once you get the hang of CAD, it honestly isn't that bad. What can I move? I can move it this way, okay. So now we're going to use the same collinear restraint again. And we are going to set those equal. Awesome. So now we have all black lines. So that means everything is constrained. You can't move any of the lines anywhere, and it's beautiful. And now this is what it looks like in 3D space. It looks just like our isometric view. We have these polygons here. And now the first main thing that you'll use is the extrude. And 90% of the things you make 3D will use the extrude because it's just the easiest. There's other ones like Revolve, which Taylor will go into later. There's Sweep, there's Loft, and there's a ton of other ones that you can do, or even just make shapes because it knows how to do that. And then so we want to select all of our faces that we want to extrude. So we're making this 2D image into the 3D space. And in our drawing, it goes up 3 feet. So we then extrude it 3 feet high. And now if we hold shift and then we press down the button on the scroll wheel on the mouse, we're able to move what we just made. So we just made the chair legs. And then now what we want to do is we want to right click on one of the chair legs and we want to create a new sketch there. And now, since we're just making the chair base, we want to go to a rectangle and we just want to make the whole thing a rectangle. And as you can see here, I guess I can constrain that. Okay, let's make you collinear. Awesome. Now we can make this collinear. Awesome. So now it's all black again. It can't move. It's all tied down in 3D space. As we can see here, we're going to take the 2D image again and we're going to create into 3D space. And this only goes up a foot. Oh, look at that. So we also have to select this face for some reason. I have no clue. But as you can see, there we go. Now, technically, yes, this is a table here, but Taylor's going to make a much better table. And then, so now we want to create our final sketch here. So we just create another sketch again. And then we use the rectangle tool again. And then this is a 1x4 by 4. And we hit enter. It's all black because we just dimensioned the whole thing and it knows exactly where it is. And then we extrude it again. And I believe this one goes up 4. Yep. So, and now we have our chair. Now, with our chair, we can do things that you can't, or it's very difficult to draw. You can do things like fillets. So I imagine if you're sitting on this chair, these edges are going to poke you a lot, and it's not going to be very comfortable. So you can do fun things like put in values, and it will actually smoothen out the edge. Or if you wanted to select multiple faces, I guess I can't do it now, but you can select multiple different things. Like let's say I wanted to do this, 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 and then this, and then let's do 0.5 here. It will create them all to make them smooth. So that is one of the things that you can use to smooth out your drawings in CAD. But if you wanted to, you can also use the chamfer. And what that'll do is it will make a little cut on this. Now, usually chamfers are, well, the main thing I've seen chamfers used for is in my DOT internship, and they actually use them on bridges because they don't want it to be straight like this, because what will happen is if a truck hits it or something, it's going to just knock off a chunk of concrete, because it's very easy to do that when, you know, there's not a lot of material around it. So they'll actually chamfer it. Oh, because can't do it that much. But if I do it like this, you can see it's not smooth, but it makes it more smooth than it was. And it's much easier to do so than trying to round it out. Is there anything else you think I should go over, Taylor, and the chair?
No, I think why don't we can do the table now if everybody's ready to go.
Awesome. So I'll stop sharing my screen now.
Awesome. All right. So let's say you just made Alex's real fancy chair, right? Here you go. Well, now we're gonna go ahead and make something else. Up here at the top, there's a little plus button that I just clicked. That'll add a new page so you can have like multiple drawings or multiple parts going at one time. I'm just gonna do that without saving the other one so it's quicker. But yeah, like Alex was saying, most of this is you're making a 2D sketch on a certain plane in 3D space, and then you can kind of create material by extruding or revolving in order to fill in the shapes that you want. And so what we'll do here is demonstrate the revolve, which is kind of the other main way of creating matter, I guess. You can't create matter, but in this sense you can, I guess. So why don't we make a 2D sketch, but this time we will do it on the right plane. So I did that super quick, sorry. So go ahead and 2D sketch, and then I'll make it on this side view. And then what I'm gonna do is, you've got all sorts of like drawing tools, right? I'm gonna make a revolved table, which means I'm gonna make like a circular table, but I'm gonna do it super easy and cheaply because it takes too much time to make like an actual circular table and try to stack circles on top of each other. So we're gonna make a simple 2D profile of one. Let's say we want like this center pole, right? And make sure that's dimensioned.
So like an easy way to visualize this is you're cutting the table in half. And this is what you would see in that half of the table that you cut off.
Yeah. So I'm just going to come up with some dimensions that might make sense. There we go. Seems legit. If you can, I don't know if you're using a trackpad or a mouse, but typically zooming in and out and manipulating the screen is relatively easy. If you can't quite figure it out, the easiest thing to do is just switch to your trackpad and use 2 fingers to zoom in and out, or 2 fingers to slide it around, by the way. Let me move this thing over there, okay. Then I'm going to add a bottom section of the table. So this will be like the table stand, and a top section of the table, which will be the tabletop. And so like Alex said, it almost looks like I cut a table in half and then took like even half of that. So if you took a quarter of a table and looked at one side of it, this is kind of the profile that you would see straight on. And without dimensioning any of those things, because we don't actually know what size we want our table to be, we'll go ahead and finish the sketch and then select all 3 of these sections for revolve. So using the revolve tool up here in create, we will select these 3 sections, and then you also have to select an axis that you want to revolve about. So once you have your profile selected axis, we will want this one on the inside where I haven't done other profiles, otherwise it'll make some goofy shape. Typically you'll start on the origin, because then you can revolve around the origin and your table will be centered around the origin. And once you click the axis, it'll pretty easily show up as like hey, this is what you're gonna get. Pretty simple table situation. And then you can also change the number of degrees on a revolve. So if I only wanted a quarter of a table, like I was talking about earlier, boom, there you go. But so now I just clicked enter, and what makes it really difficult if you don't know what you're doing here is I have no way of going back, and from what I can see, I have no way of going back and changing this revolve so that I have more than a quarter of a table. So then down here on the bottom, you'll see kind of like this timeline thing. It shows you all of your sketches and then all of the actions you create. So the most recent one was my revolve. You can see that. And if I right click, I can edit the feature, and that will bring back up my my edit feature window, so I can change it from 90 degrees to 360 again, so we get a whole table rather than just a quarter. So like Alex was showing you earlier, there's plenty of ways to modify what you're doing. Some of those things include chamfers and fillets, but something you can also do is if you rotate to the bottom of the table you can see there's kind of this face, and let's say, oh, this table is made out of steel. It's like 100% steel. We don't want to make it solid steel. We want it to be pretty light. So we have this option of a shell. And what a shell do is, like you can see in this picture here, you pick one face and it will hollow out the rest of the material given the face that you select. So I'm going to select the bottom face because I don't want any other face to be open to whoever's sitting at my table. And then you can choose an inside thickness. I'm going to choose 0.01 inches just so it's super thin, super light table. So you don't have to be a big, strong guy to lift this one up. So now you can see, obviously you can't see all the way down into the table, but you can see that there's kind of like this weird looking lip. It is as if this table is now made out of like sheet steel or something. One of the other ways that you can edit your parts is by putting holes in it or removing material. And so you do that in the same way that you would use an extrude, but you just swap it to a cut. So I'm going to go ahead and put a sketch in on the top plane. We're going to make a little hole for an umbrella on the top. So just a circle right in the center. Use the origin as your point pretty much always. And then hopefully if I dimension it, if I don't dimension it, we'll be all right. If it's too wide, it might just cut through the post, but we'll see. And then go ahead, click extrude, select the profile that you want to extrude, and then here's where you have the option to change whether or not you're creating material or taking away. So I can slide this little arrow up to kind of visually see what I'd be making. I don't want that. I don't want to create the umbrella. I want to make a hole for the umbrella. So I'm going to instead say cut, and I want it to go this direction. You can also obviously dimension that. So maybe we want it to be 10, so it goes all the way down to the bottom. Excuse me. But it's turned red, so that means that my hole for my umbrella was too large, and it would have actually just removed the entire center pole of the table there. So the tabletop would have fallen down onto the bottom. So I'm going to go ahead and cancel, and then go down here to that timeline that I was showing you earlier. Right click, edit my sketch, and put a dimension on there that is smaller than what it is currently. So I think my hole is actually 2 inches in diameter. I'm going to make it 1 inch, little bitty umbrella. And then we'll go back, do the extrude, select the face, change it to a cut. And then we want to go -10 inches into the table. Bingo. So now I didn't cut away my center pole of the table, but I also have a hole going straight through that I could slide an umbrella down into. So something to note about the shell function, it's kind of a path of no return. So once I've done the shell, I can't go back in and easily create a chamfer or a fillet like Alex was showing you with the chair. If I were to try that now, I would get like this section of the table cut out, and the entire rim of the table would no longer be attached. Other than that, there are some more detailed, like non-creative methods to like alter your parts. So you can actually create assemblies, which means you'll create like 2 different parts, and then you can fit them together using mates. And then you can also, if you want to go I guess if you want to go this far, you can go ahead and do stress testing, which means, okay, if I set a rock on my table, how much weight can this table handle? Like how heavy can the rock be? Where can the rock be set so that the moment does it tip the table over? And you can actually see that simulated in real time. But other than that, we've got our table, we've got our chair. Does anybody have any questions about CAD? I know this is just a very general flyover. I don't know how many of you have used CAD in the past, but are there any questions? I think you can go ahead and type in the chat if you have a question, and then we can unmute you or something. If not, I guess that's all
I can go into
Go ahead,
a feature of planes and moving planes real quick.
Sure, go for it.
All right. So let me share my screen. All right. So with my chair here, let's say I want to make a giant spear that goes through it at an angle like this way. So what we're going to have to do is we're going to have to offset and plane. So you can see our three-dimensional system down here. It doesn't change as you scale it. So there's a bunch of different features. You can create a new plane off of a plane that's already existed. You can create an angle. You can create tangent to a plane, mid-plane. It's basically endless. You can, anything you can think of. And what a plane is where you build on. Like for us, the plane that we built on was the XY plane. And so if we want to do this, we're going to have to offset a plane from the XY here. So let's do no, not 23. Okay. 5 feet. Yep, perfect. So now we have another plane here. And now we're going to want to make one at an angle from here as well. Can I do that? Let's just do it from down here. So now if you wanted to, you could sketch on this plane and build whatever you want. Let's say you wanted to make a person there, but didn't have them touching the chair. You could do that. But I'm actually going to make a plane that is tangent to it like this, -50. And then you can see all of your construction planes here. So I can see plane number 1, and where did this one go? I do not know where this plane is. That is very confusing because it's not showing up on the screen. I've never had that happen before. Oh, it's this itty bitty thing down here. What the heck? What the heck? Okay, so you can make a sketch on that. It's fine. It works, but I don't know why it's so small. That's really weird. And so now, if we look at our plane,
your chair is so big.
What?
It's because your chair is so big. Your chair is like 50 feet tall.
I know, but I don't know why the plane scaled so small. That's weird. So now, as you can see, it's not tangent to anything. It's kind of doing its own thing. It's 50 degrees off of that axis. So now we want to create a sketch. Actually, we're going to have to offset another plane. Okay, so this is kind of what I was talking about earlier. So now we offset a plane off of plane 2. Here we go. 5 feet. Okay, so now we're here. Perfect. So now we want to draw on this plane. So again, you can find everything you've done here in this menu here. So you can see the bodies you made, which is the whole chair. You can make all of this, you can see all of your sketches that you made, which we made 4 sketches to get us to that point. And you can see all of our planes as well. So we want to, I want to let me create a sketch on it. Oh my gosh. Okay, there we go. We finally got it highlighted. And now we want to create our spear. So let's just make a rectangle here like this. But we're going to have it not exactly halfway because we're going to do a revolve feature. Then around that axis. And then we want to add, we don't want to cut. There we go. And now we have a spear going through the chair. So if you ever wanted to know what a spear going through a chair looks like, that's what it looks like. So that's how you use planes. It's basically moving your 3D space and manipulating it to do things that you can't do this while sketching on any one of the 3 axes. I mean, I guess you could, but it would take you forever. So it's much easier to just use a plane and cut through whatever you're doing. Do you have anything to add to that, Taylor?
No, I think just for everybody, so CAD is typically used in the workplace by mechanical civil engineers. for the most part. Like we spend a large majority of our time doing this and other math problems that are related to it. So what I would say is, if you want to learn CAD, it's probably more beneficial to those of you that are not engineering majors to use a direct modeling CAD such as Blender or Maya, something where you can create artistic shapes and move them in physical space rather than making technical drawings in order to manufacture. All right, well, thank you very much, everybody. I guess if you want to stick around, I imagine Caitlin will end the recording, and then we will be here for questions, or just if you want to chat about something, go ahead. I know Mike said he wanted to talk about a roller coaster, so.
Awesome. Thank you, everybody.